In the last lesson, we create three objects: quad object, hard service, subservice. We go for our code in Unity. This is the three objects. Now, if we check our code, we found in the vertices for build a quad, the first vertices was in the 0 point and second in 0, 5, 0. Now, if we go soft service code, again, it is in the 0 point or the origin of the point and 0, 5, 0. If we go in the hard service, you'll find again origin point and 0, 5, 0. Now, it's look like confusing. How we got three objects in three different locations, but we assign the points in the origin point, the first point for all of three objects. It should be matching all together. This is what we are going to explain in this lesson. First, I am Athir. I'm a creator of Digital Touches, and I am here to explain to you what's happening. First, we need to study the rendering process at Unity in short. In rendering process, Unity, to convert our code to the screen, it's going through multi-steps. And these steps start by studying the vertices or coordination at the model space, which means our model, how we build it, or our mesh. Then it will transfer it to the world space. So it will change the coordination from the model space or from the object space or object vertices to the world coordination, which means the game coordination. But we are not seeing the whole world. We are seeing the camera. We are seeing what camera see at the world space. So then we are changing the coordination to the camera space, and from camera space, actual camera space, it's a 3D space. So we have, but the screen, what we are seeing is 2D, the flat screen that we are watching our game through it. So we're changing the space from 3D space to space through process clipping volume space. And finally, we do all the necessary calculation to prepare it for the screen through a screen space. So, to understand what happened in Unity, how to create three objects with the same vertices in three different locations, we need to study the model space and the world space. In Unity, each game object have a transform component, which is considered as the origin point for the game object. So, in model space or in our mesh, once we assign the vertices consider the point 0, 0, 0 is the same the transform point. So when we add any point, let's say 1, 0, 3, 0, it will go from the transform point 0, 3, 0. It will not consider the original space or the environment around it, or let's say the game space. It's only consider in this point what is our game object space. So model space is you can say it is the same as the local space or the object coordinates. And all points in this point refer to the origin point of the model. So in this example, we have triangle, and let's say this triangle going in the game object, or let's say it's going in the environment or the game space. It's moving like 1, 2, 3 space and 1, 2 in y-axis, and it's 0 in the z-axis. Now, once we assign the point 0, 0, 0, it will not go to the game or the environment or the game space. It will go 0, 0 in the origin point of the object, which means this point, as the transform of the object. So, once we assign the point 1, it will be 0, 3, 0. It will go 3 up in y direction, referring to the origin point, which is the transform point of the game object. And again, point 2, 3, 0, 0, it will be referred to the origin point of the game object itself. In the world space, the situation will be different. Now, you can see if we look here, in the world space, we have 0 point for the whole world or for the whole game. So this 0 point will be fixed for all game objects. If I have 10 game objects, all will be referred for this point. So which is 0, 0, 0 of the world or the game, let's say environment. So world space is the game space itself, and all points refer to the origin point of the game. So we have one reference. Now, In this point, if we say we will use the WorldSpace coordinate for our game object, let's use the same game object from the previous slide. We say we are moving x3 and y2. So in this point, instead of the point which was 0, 0, 0 in the model space, it's now become 3, 2, 0 in the world space, because the point have the reference 0, 0, 0, it's represent the game transform which is in this point. However, the game transform comparing with the whole world, it is 3, 2, 0. It's in the location 3 from the origin point of the world and 2 in the y and z 0. Now, you can see how the transfer will become. All model space point will be added. You can add to it the points or the coordinate of the transform point or the origin point of the game object. So the upper point it becomes 3, 5, 1, and the second point becomes 6, 2, 0. So if we back now to the C# code, you will find again in our code build quad. Once we assign the vertices point, these vertices coordination was in the model space. We assign when you assign for the mesh, you are assigning for the model space. You not assign for the world space. So all the points here in the mesh, it will be relative to the origin point or of the game object, which means the game object transform. Same point in the soft surface. Same point in the hard surface. So all these points all now assigned for the model space. Now if we back to Unity itself, you can see our free game object. If we look to the transform component, the first object was in the 0, 0 of the whole world. Now again this dimension you see here the 0, 0, 0 of the whole world. Now you can see the second object, the position was different. So all the vertices assigned for it, it was relative for this point. So all these coordinates will be added to the local coordinate or the model space point. Again, the third object, again the transform space or the position is different. So the origin point was shifted. Then all the points in the model itself, it will be shifted. And this is in general how Unity handling or many game objects. First, any game object, you need to remember it will be save all the vertices of the model space, mean the special space for the game object. Then it will be transferred from that space to the world space. And that's it. Thank you. At the end, if you like the video, press subscribe and turn on the bell, and don't forget to share your opinion below in the comments.